TCAP Math 8 Subpart 3. Question number 19. Quadrilateral Qrst and its image Q', R', S', and T' are shown. What is the sequence of transformations that result in quadratic Qrst being mapped onto Qrst prime? If you notice your answer choices, they all have something in common. They all have a scale factor of 2. And clearly you're seeing that this is being enlarged. When you're multiplying by a scale factor larger than 1, it's getting bigger. If you're multiplying by a scale factor that is less than 1, remember it's getting smaller. So this is my original figure, and it is getting larger. Now what we have to figure out, is this a reflection, which means a flip? Is it a rotation, that means a turn? Or is it a translation, which just means it's sliding over? And the last one is also talking about a rotation. If you pay close attention to your top 2 letters, Q and R, notice that Q and R are your bottom 2 letters. So that is an indication of a reflection. It's being flipped over that x-axis. Number 20. Raul recorded the height in inches and the weight in pounds of each of his soccer team members. Then he graphed the data in the scatter plots shown. Which 3 statements about the scatter plots of the data are true? If you notice these cluster points, try to draw a line of best fit the best you can through this data point. It'll help you answer these questions. If you're able to draw a line, that tells you that you have a linear association. P says the data has a positive association. If you notice that your line is going up and that your line is positive, the data has a negative association. Well, if you have a positive association, you can't have a negative association in a linear association. As the height increases, so does the weight. And if you notice, your numbers are getting higher and your weight is getting higher. So the data points, for example, if you look at this last point right here, 70, 140, so the height increases, so does the weight. Becky and Luke bought some of the same kind of pencils and erasers. Becky spent $1.45 for 2 pencils and 3 erasers. Luke spent $2.65 for 5 pencils and 1 erasers. What we're going to do, there's several options that you could do here, as you can figure out which one is the erasers, different strategies that you can use. That's absolutely fine. One strategy that I'm going to use is using a system of equations. I'm going to take Becky and I'm going to create an equation for Becky. I'm going to use P for pencils and E for erasers. Becky did 2 pencils. She bought 2 pencils plus 3 erasers, and she spent $1.45. Luke he bought 5 pencils and 1 eraser for $2.65. So if I'm doing elimination here, I would want something to eliminate, either my P's or my E's. And I notice here that if I made that a negative 3E, then my E's would eliminate. And so that's what I'm going to do. I'm going to multiply this entire equation by negative 3. The first equation I'm not going to change. I'm just going to bring it over. 2P plus 3E equals $1.45. And then for my second equation, I'm going to multiply by negative 3, distribute that in. So negative 3 times 5P gives me negative 15P. Negative 3 times 1E gives me that negative 3E. See how they're opposites and they're going to cancel out. $2.65 times negative 3 is going to give me negative 7.95. So I'm going to add these up, just kind of creating a big addition problem. Add up your P's. 2p plus negative 15p is going to give you negative 13p. These are opposites. They're going to cancel out. They are going to eliminate. That's the name of the game. Then $1.45 plus negative $7.95 is going to give me negative $6.50. So then what we're going to do is just solve this simple equation, divide by the coefficient by negative 13, and P, remember, stands for your pencil, is going to be 50 cents each. Now remember, we're trying to solve for the eraser, so don't circle or choose 50 cents just yet. We got to figure out what the eraser is. So you can plug 50 cents into any of these equations. It doesn't matter which one. This one right here might be the easiest. 5 times 50 cents plus E gives us that $2.65. 5 times 50 cents gives us $2.50. And again, we're just solving for E. So if you notice, we're subtracting $2.50 from both sides, and I think you guys can probably already guess to figure out what the eraser is going to be. 15 cents. Squeeze that in there for one eraser. (22) A ski lift is used to transport skiers to the top of the slope. A certain ski lift is 3,000 meters long. The graph represents the relationship between the number of minutes in the ski lift X and the distance traveled. So when you look at these answer choices, it asks, what is the slope? Your slope is your rate. Your slope is rise over run. You could also think of your X over your Y's. This is proportional. It goes through the origin. So we can simply just do Y divided by X. If you look right here, you can see 500 divided by 1. That reduces down to 500. Just make sure that your Y is on top of your fraction. That's your rise. So the ski lift travels 500 meters every minute. Part B is saying the ski lift travels 1 meter every 500 minutes. Well, that's getting the ratio backwards. Then it says the rate of the ski lift increases every minute. Well, it increases 500 meters every minute. And then the last choice, the rate of the ski lift decreases. Well, clearly we have a positive slope here. Number 23, which set of ordered pairs represents a function? Select all that apply. There's a lot of definitions for function. One that I like to think about is where a function is where your x values do not repeat. They're all different. So if you look at A and just look at the x values, well, the x values there repeat, so that is not a function. 1, 2, 3, 4, they're all different, so that is a function. 1, 2, 3, 4, they're all different, it's a function. Notice I'm not even looking at my y values. It doesn't matter about your y values, it just matters about your x. 1, 2, 1, that repeats, can't be a function. 1, 2, 3, 4, there's our functions. Which equation has infinitely many solutions? Well, there's 3 categories when you're solving an equation, and you can base them on slope-intercept form. If I have one solution, you might have something like 2x plus 3 equals 4x minus 6. 2 and 4 are going to represent your slope. 3 and negative 6 are going to represent your y-intercepts. If you notice, your slopes are different. And when your slopes are different, let's just say different slopes. And it doesn't matter about your y-intercepts, but if you have different slopes, you're going to have one solution. That means if you graphed them, they would cross one time, one solution. No solution would look something like, let's say 5x plus 2 equals 5x plus 3. Notice you have the same slopes, but you have different y-intercepts. Same slopes, different y-intercepts. What this would look like is parallel lines. They would never cross, so therefore, if they never cross, they're never going to have solutions. And then the last one would be your infinitely many solutions. And this one's easy to memorize because everything will look the same. 4x minus 2 equals 4x minus 2. You're going to have the same slope. You're going to have the same everything, the same y-intercept, the same everything. So if you look at these answer choices, you've got to figure out which one has infinitely many solutions. So if you clean them up a little bit, you notice here that you're going to have 11x plus 1. Over here you have 5x. Now remember 5x and 11x, that's going to give you one solution. So that's not what we're looking for. Here I have negative 4x and 4x. Those are different. Again, you'll have one solution. 3x plus 4, and then combine your like terms. That'll actually give you 3x plus 2. So you've got the same slope, but you don't have the same y-intercept, so that's going to be no solution. And then I'm hoping it's the last one because we haven't circled anything yet. 3x take away 2x will be 1x plus 2. And you notice on the other side you have x plus 2. Everything is exactly the same. So that one is infinitely many solutions. Number 25, the average distance from Earth to the Moon is approximately 238,900 miles. What is the distance in miles written in scientific notation? Notice this is a calculator question, so you can plug this in your calculator. Keep in mind that these are very old questions, so you might find this question pop up under the non-calculator section. So we need to know how to do it both ways. So in this number, 238,900, you have to know where your decimal is. Your decimal is at the very end of this problem. It needs to be between the 2 and the 3. You want to have one digit that's a non-zero number to the left of the digit. So we'll have 2.389. We don't need the rest of these zeros. Remember, scientific notation is a shortcut. It's always based at a power of 10. We moved this decimal from the end 1, 2, 3, 4, 5 spaces. Sometimes that would be a negative 5 if this was a small number, putting it in scientific notation. But if this is a very large number, then we're going to have a positive exponent. A cell phone company charges $20 for a new customer to open a new account, and $35 for each month of the phone service. Write a linear function to represent the total cost y, and a new customer would pay for X months of service. Write your answer in the space provided. Linear function. Whenever you see linear function, I want you to be thinking about slope-intercept form. That is our example of linear function. And what I would recommend is that you go ahead and put it in your answer document, just like this. And then fill in the necessary numbers. 20 is your starting value, so I'm going to plug it in for B. I know that it's my starting value because they're talking about opening a new account, so you have to look for your keywords. 35 is my slope because it's talking about for each month of phone service. Remember that your slope, your rate, is always comparing 2 units of measurement. Here, I have money and time, 2 units of measurement, so I know that's my slope. 27. The table represents a proportional relationship. Which graph represents the proportional relationship with the same unit rate as the table? Remember, proportional means going through the origin, and every single one of these goes through the origin. So we're just going to test these points. You've got 1 and 4. Well, that's up there. 1 and 4. Nope. 1 and 4. Nope. 1 and 4. Bingo. It's D. And you can test the rest of these points. 1.5 and 6 and 2 and 8. We're spot on. 2.5 and 10. Absolutely. Number 28. A rectangle has a width of 28 centimeters and a length of 75 centimeters. What is the length of its diagonal? Your key word is your diagonal. That means you're finding the hypotenuse of a right triangle. You can use this box right here. Think about finding the diagonal of this box. You've got two right triangles within this box. Let's say you have a height of 28 and a length of 45, and you want to solve for this hypotenuse. There's two formulas that you need to memorize for your Pythagorean theorem. If you are trying to find a leg, then you would take the hypotenuse. If you're trying to find the hypotenuse, you would take the square root of the leg raised to the second power plus the leg raised to the second power. If you are trying to find a leg, which we are not, we're trying to find the hypotenuse. The hypotenuse is your diagonal. So anytime that you're finding the diagonal, you need to find the hypotenuse. But if you're trying to find the leg, like we have in previous questions, you would take the square root of the hypotenuse raised to the second power minus the leg to the second power. This is a calculator question, so you'll need to plug into your calculator. So the hypotenuse equals the square root of 28 to the second power plus 45 to the second power. Make sure you get familiar with your calculator before the test. And that gives you a hypotenuse of 53. So 53 should go in the box.